Picture a galaxy unlike any other, one that defies everything we thought we knew about the cosmos. Meet NGC 1277, a cosmic oddball hiding in plain sight, packed with mysteries that leave astronomers scratching their heads. This isn't just another speck in the universe. It's a relic from the early days of creation, frozen in time, and brimming with bizarre objects that challenge our understanding of space. Today, we're diving deep into this galactic enigma to uncover 25 of its strangest secrets. From a supermassive black hole so colossal it shouldn't exist to ghostly filaments of gas weaving through the void, each discovery is more mind-bending than the last. Why does this galaxy lack dark matter? How did it stop making stars billions of years ago? And what's the deal with its oddly quiet black hole? Stick around, because by the end of this journey, you'll see why NGC 1277 isn't just another galaxy. It's a cosmic puzzle that could rewrite the rules of astrophysics. Ready to explore the unknown? Let's go. Now let's zoom in on the heart of the mystery, the colossal supermassive black hole lurking at the center of NGC 1277. This isn't just any black hole. It's a behemoth so enormous that it defies logic, tipping the scales at an estimated 17 billion times the mass of our Sun. To put that in perspective, the supermassive black hole at the center of our own Milky Way, Sagittarius, a star, is a mere featherweight in comparison, clocking in at around 4 million solar masses. Scientists first stumbled upon this cosmic giant back in 2012, and it immediately sent shockwaves through the astrophysics community. Why? Because according to our current models, a galaxy as small as NGC 1277 shouldn't host a black hole this massive. Typically, the mass of a galaxy's central black hole makes up about 0.1% of the galaxy's total stellar mass. But here, the black hole accounts for a staggering 14%, a ratio so extreme it's like finding a bowling ball sitting inside a teacup. What makes this even more baffling is how it challenges our understanding of black hole formation. One leading theory suggests that supermassive black holes grow by merging with others or by voraciously consuming nearby gas and stars over billions of years. But NGC 1277's black hole is so disproportionately large that it raises a spine-tingling question. Did it form differently, perhaps from the direct collapse of an enormous gas cloud in the early universe? Or was this galaxy once far bigger, only to have its outer stars stripped away by some cataclysmic event, leaving behind this dense core with its overgrown black hole? The implications are staggering. If black holes can grow this large relative to their host galaxies, it might mean we've been underestimating their role in shaping galactic evolution. Some researchers even speculate that NGC 1277 could be a rare relic of a bygone era, a frozen snapshot of a time when the universe's first monsters ruled the cosmos. But here's the twist: despite its mind-boggling size, this black hole is strangely quiet. Unlike active galactic nuclei that blast out jets of energy, this one seems to be in a deep slumber. Why isn't it devouring everything around it? That's a puzzle we'll tackle later in our journey. For now, just let that sink in: a black hole so massive it rewrites the rules, sitting quietly in a galaxy that refuses to play by them. And believe it or not, this is just the first of 25 cosmic oddities waiting to unravel in NGC 1277. Now let's peel back another layer of this cosmic enigma. How does a black hole this monstrous shape the galaxy around it? The gravitational grip of NGC 1277's supermassive black hole isn't just strong, it's rewriting the rules of galactic architecture. Picture this: stars near the core don't orbit lazily like planets around the Sun. They're whipped into frenzied, high-speed orbits, some reaching velocities of over 3 million miles per hour. That's fast enough to cross the entire United States in less than a second. This chaos creates a bizarre stellar dance where the black hole's gravity acts like an invisible puppeteer, yanking stars into tight, erratic paths and even flinging some entirely out of the galaxy. But the drama doesn't stop there. Gas clouds, the raw material for new stars, face an even harsher fate. Instead of cooling and collapsing into stellar nurseries, they're torn apart by tidal forces or heated to millions of degrees, glowing violently in X-rays before vanishing into the black hole's maw. This explains why NGC 1277 is eerily devoid of young, blue stars. The black hole is essentially strangling star formation in its cradle. Now, how did this cosmic titan end up in such a modest galaxy? Here's where the plot thickens. One theory suggests NGC 1277 was once a far larger galaxy, possibly the core of a massive cluster that got stripped down over eons. Imagine a cosmic tug-of-war where neighboring galaxies siphoned away its outer stars, leaving behind this dense, black hole-dominated relic. Alternatively, some scientists propose a far wilder idea, that this black hole didn't grow gradually but formed in a single, catastrophic collapse during the universe's infancy. In the primordial cosmos, where conditions were extreme, a giant gas cloud might have bypassed the usual stellar steps and imploded directly into a supermassive black hole. What's undeniable is that this black hole's existence throws a wrench into our galactic evolution models. If such leviathans can form in small galaxies, it hints that black holes might not just be passengers in a galaxy's life. They could be the architects sculpting their homes through sheer gravitational might. And yet, despite its overwhelming influence, NGC 1277's black hole remains eerily quiet, a slumbering giant whose past violence has left behind a galaxy frozen in time. Up next, we'll tackle another puzzle: why this galaxy seems to be missing something every other galaxy has: dark matter. Now let's shift our gaze to something even more baffling. NGC 1277 isn't just missing young stars, it's missing something far more fundamental: dark matter. This invisible glue, which normally makes up around 85% of a galaxy's mass, seems to have ghosted this galaxy entirely. Picture a spinning carousel. Normally, dark matter acts like hidden weights, keeping the outer riders from flying off as the carousel speeds up. But in NGC 1277, the outer stars are moving suspiciously slow, as if those weights were never there. Scientists first noticed this anomaly by studying the galaxy's rotation curve, a graph plotting how fast stars orbit at different distances from the center. In most galaxies, the curve stays high far out, betraying dark matter's presence. Here, it plunges sharply, like a roller coaster dropping off a cliff. How do you lose something you can't even see? One possibility is that NGC 1277 never had much dark matter to begin with. Some theories suggest it formed in a rare, ultra-dense pocket of the early universe where normal matter crowded out dark matter. Alternatively, its dark matter might have been stolen. If this galaxy once orbited a larger cluster, gravitational forces could have ripped its dark matter away, leaving behind a luminous skeleton of stars and gas. There's even a wilder idea that the black hole's extreme gravity somehow expelled the dark matter, though that's like blaming a tornado for vacuuming up an entire city. This absence isn't just trivia, it's a direct challenge to how we think galaxies are born. Current models insist that dark matter halos are galactic wombs pulling in gas to form stars. Yet here's NGC 1277, a thriving galaxy that apparently skipped that step. If galaxies can form and persist without dark matter, it forces us to rethink everything from cosmic evolution to the nature of gravity itself. Some researchers now speculate that this might be a sign of modified gravity theories, where the rules change in extreme environments. Others argue it's proof that dark matter isn't as universal as we thought. One thing's certain: NGC 1277 isn't playing by the cosmic rulebook. While most galaxies cling to their dark matter like security blankets, this one tossed yours away and still managed to survive billions of years. Up next, we'll meet the galaxy's ancient stellar resident stars so old they remember the universe's toddler years. Now, let's turn our attention to the celestial elders of NGC 1277 stars that have been shining since the universe was in its infancy. Unlike most galaxies, which host a mix of young, middle-aged, and ancient stars, this one is almost exclusively home to stellar retirees. These ancient stars, clocking in at over 10 billion years old, tell us something extraordinary. NGC 1277 effectively shut down its star-making factory long before many other galaxies even got started. Imagine a bustling city where no new buildings have been constructed for billions of years. That's NGC 1277, a galactic relic frozen in time. Normally, galaxies recycle gas and dust to birth new stars, but here, the process ground to a halt so early that the youngest stars are still older than Earth itself. Astronomers call this a quenched galaxy, a term that makes it sound like someone flipped a cosmic off switch. What could have caused such an abrupt halt? One leading theory points to the galaxy's monstrous central black hole. When black holes feed, they unleash torrents of energy that can heat up or blow away the cold gas needed for star formation. In NGC 1277's case, the black hole might have gone on a rampage in its youth, sterilizing the galaxy so thoroughly that it never recovered. Another possibility is that the galaxy simply ran out of fuel. If it formed in a region where gas was scarce or was stripped away by cosmic encounters, its star-forming days would have ended prematurely. But here's where it gets even more fascinating. These ancient stars are also unusually metal-poor, meaning they contain fewer heavy elements like iron and oxygen compared to stars in other galaxies. That's a big deal because metals are forged in stellar furnaces and scattered by supernova. The lack of metals suggests NGC 1277 stars formed before the universe had time to pepper space with these elements like a recipe made before all the ingredients were invented. This aligns with the idea that the galaxy assembled its stars in a frenzied rush during the universe's first few billion years, then went quiet. Why does this matter? Galaxies like NGC 1277 are essentially cosmic time capsules. Their old, untouched stellar populations offer a pristine snapshot of conditions in the early universe, free from the pollution of later star formation. By studying them, astronomers can piece together how the first galaxies grew and why some, like this one, hit the pause button so early. It's like finding a perfectly preserved fossil that challenges our timeline of galactic evolution. Up next, we'll zoom in on the galaxy's mysterious entourage, ultra-compact dwarf objects that might be the mangled remains of even older galaxies. Could these be the missing pieces of NGC 1277's puzzle? Stay tuned. Now, let's shift our gaze to the intriguing cosmic companions circling NGC 1277 ultra-compact dwarf objects, or UCDs for short. These tiny but mighty stellar systems pack hundreds of thousands of stars into a space just a few hundred light-years across, making them some of the densest objects in the universe. Imagine squeezing a globular cluster's worth of stars into a region smaller than most galaxies' cores. That's the kind of extreme density we're talking about. What makes these UCDs particularly fascinating is their ambiguous origin story. One leading theory suggests they're the surviving nuclei of larger galaxies that were torn apart by NGC 1277's immense gravity. Picture a cosmic tug-of-war where smaller galaxies ventured too close, had their outer stars stripped away, and left only their densely packed cores behind. If true, these UCDs could be the mangled remains of galaxies that met a violent end billions of years ago. But there's another twist. Some astronomers argue these objects might not be galactic leftovers at all. Instead, they could be supermassive star clusters born from a frenzy of star formation in NGC 1277's chaotic youth. The difference: star clusters form naturally from collapsing gas clouds, while galactic nuclei are the central hubs of pre-existing galaxies. Telling them apart isn't easy, but clues lie in their chemical makeup. UCDs that once belonged to galaxies tend to have richer metal content, a relic of their star-forging history. Here's where NGC 1277's UCDs throw a curveball. Some of them are surprisingly metal-poor, much like the galaxy's ancient stars. This raises the possibility that these objects formed in the same primordial rush that built the galaxy itself, making them not invaders, but original members of this cosmic relic's entourage. It's as if we've stumbled upon a celestial family portrait frozen in time. The mystery deepens when we consider how these UCDs orbit their host. Unlike the orderly paths of most globular clusters, some of these objects follow wild, elongated trajectories. That could hint at a turbulent past where gravitational tugs of war flung them into unusual orbits, yet others move in neat circular patterns, suggesting a quieter history. This mix of behaviors keeps astronomers debating whether these UCDs are all cut from the same cloth or a patchwork of different origins. Why does this matter? Ultra-compact dwarfs are like cosmic Rosetta Stones. If they're shredded galaxy cores, they could reveal how NGC 1277 grew by cannibalizing its neighbors. If they're native star clusters, they might shed light on the extreme conditions of the early universe. Either way, they add another layer to the puzzle of why this galaxy looks so unlike its peers. Up next, we'll unravel another oddity, the eerie, thread-like gas filaments weaving through NGC 1277's void. What forces sculpted these ghostly tendrils, and what secrets do they hold? The answers might just rewrite what we know about galactic atmospheres. Now, let's turn our attention to one of the most hauntingly beautiful features of NGC 1277, the delicate, thread-like gas filaments that weave through its surroundings like ghostly ribbons in the cosmic wind. These wispy tendrils of ionized gas stretch for thousands of light years, glowing faintly against the void, but don't let their ethereal appearance fool you. These filaments are cosmic crime scenes, holding clues to violent events that shaped the galaxy's history. The first big question is, where did these filaments come from? One leading suspect is the galaxy's supermassive black hole. When black holes feed, they don't just swallow matter, they also belch out colossal jets of energy and radiation. These outbursts can strip gas from the galaxy's core, hurling it outward in long, streamer-like formations. Imagine blowing on a dandelion and watching its seeds scatter. That's sort of what happens when a black hole's fury reshapes its surroundings. But there's another possibility. These filaments might be scars from a past galactic collision. When galaxies brush against each other, their gravitational tug of war can stretch gas into bizarre filamentary shapes. Picture two clumps of taffy pulling apart, leaving behind sticky strands. That's the kind of messy aftermath we could be seeing here. Supporting this idea is the fact that some filaments appear to connect NGC 1277 to other faint structures in the distance, like cosmic breadcrumbs leading to forgotten encounters. Here's where it gets even stranger. Unlike the chaotic filaments seen in other galaxies, many of NGC 1277's threads are oddly organized, almost forming a loose web around it. That's unexpected because black hole winds and galaxy collisions usually leave behind tangled, chaotic messes. This neatness has led some researchers to wonder if magnetic fields are playing puppeteer, guiding the gas into these eerie, orderly patterns. Then there's the mystery of what's lighting them up. Filaments like these usually glow because they're bathed in radiation from young stars or the black hole itself. Yet NGC 1277 is famously red and dead, with no recent star birth and a quiet black hole. So what's energizing these filaments? One tantalizing theory suggests they're being illuminated by leftover energy from ancient black hole outbursts, like echoes of a scream in an empty hall. Why do these ghostly threads matter? For starters, they're a fossil record of the galaxy's most dramatic moments. By studying their shapes, speeds, and chemistry, astronomers can piece together whether it was black hole tantrums, galactic smash-ups, or something even weirder that left these marks. Plus, filaments like these might act as cosmic highways, channeling gas back into the galaxy to fuel future star formation, if NGC 1277 ever wakes up from its slumber. Up next, we'll explore why this galaxy earned the label red and dead, and how its refusal to form new stars defies everything we thought we knew about galactic life cycles. What turned NGC 1277 into a cosmic relic? The answer might lie in its stubborn silence. Shifting our gaze to another baffling aspect of NGC 1277, we encounter its eerie classification as a red and dead galaxy. This label isn't just poetic, it's a cosmic death certificate. Unlike vibrant spiral galaxies brimming with blue-white young stars and glowing nebulas, NGC 1277 is a graveyard of aging suns, its light dominated by the reddish glow of ancient stellar embers. But how did this galaxy become a celestial fossil, and why does its existence rattle our understanding of galactic life cycles? The red and dead designation hinges on two glaring absences: star formation and the cold gas needed to fuel it. Most galaxies, even elderly ones, retain pockets of hydrogen gas that occasionally spark new stars. NGC 1277, however, appears to have exhausted its reserves billions of years ago. Think of it like a fire that burned through all its kindling, now only ashes remain. Yet this isn't just a quiet retirement, it's a rebellion against expectations. Current models suggest galaxies this compact should still be churning out stars, fueled by gas funneled inward by their dense structures. NGC 1277 defies that logic, leaving astronomers scrambling for explanations. One theory points to its monstrous black hole as the culprit. When supermassive black holes feast too greedily, their energetic outbursts can blast gas clear out of a galaxy, starving it of star-forming material. It's like a cosmic hurricane stripping a tree of its leaves before they can bloom. But here's the twist: NGC 1277's black hole isn't active now. Did it rage violently in the past, permanently shutting down star birth before going silent? Or was the gas stolen by another mechanism entirely? Then there's the isolation factor. Nestled far from bustling galaxy clusters, NGC 1277 may have avoided mergers that typically replenish gas supplies. Imagine a hermit who never visits the market. Eventually, their pantry runs empty. Yet even this explanation feels incomplete. Other isolated galaxies show at least sporadic star formation. Why is this one so stubbornly barren? What truly unsettles scientists is how young the universe was when NGC 1277 died. Its stars formed in a frenzy over 12 billion years ago, then abruptly stopped when the cosmos was just a fifth of its current age. This timeline clashes with the gradual aging we see in most galaxies, as if NGC 1277 skipped middle age and leapt straight to senescence. Some argue it's a relic galaxy, a pristine survivor from the universe's chaotic youth that avoided later mergers, freezing it in time. If true, it's like finding a medieval castle untouched by modernity, its original architecture intact. The implications are profound. If more relic galaxies exist, our models of galactic evolution might need rewriting. Perhaps the early universe birthed entire generations of galaxies that burned out rapidly, leaving behind these red ghosts. Or maybe NGC 1277 represents a rare, extreme outcome of black hole feedback. Every unanswered question it poses is a crack in our cosmic understanding, one that future telescopes might pry open wider. As we peel back another layer of this galactic enigma, we're left to wonder: is NGC 1277 a celestial outlier or a signpost pointing to hidden chapters in the universe's story? Next, we'll examine the clusters of ancient stars orbiting this galaxy, globular clusters that hold secrets even more archaic than the galaxy itself. their unusual chemistry might rewrite the history of this cosmic relic. Now, let's turn our attention to one of the most intriguing cosmic relics orbiting NGC 1277, its mysterious globular clusters. These dense, spherical swarms of ancient stars are like time capsules, preserving clues about the galaxy's violent infancy. But what makes them truly extraordinary is how they defy expectations. Unlike the globular clusters seen in most galaxies, which span a range of ages and compositions, NGC 1277's clusters are uniformly ancient and shockingly devoid of heavy metals. This isn't just a curiosity, it's a window into the brutal conditions that shaped this galaxy billions of years ago. Globular clusters are typically thought of as galactic fossils, but these ones are more like primordial relics. Most galaxies, including our Milky Way, host clusters with a mix of stars, some older, some slightly younger, with varying levels of elements like iron and silicon forged in stellar explosions. NGC 1277's clusters, however, are almost exclusively made up of stars that formed within the universe's first 1 to 2 billion years. Their metal content is so low it suggests they were born in an environment nearly untouched by the chemical enrichment that later generations of stars provided. Picture a pristine ice core sample from Earth's earliest atmosphere, uncontaminated by later industrial activity. That's how untouched these clusters are. What does this tell us about NGC 1277's origins? For one, it implies the galaxy formed in a region of space that was unusually barren even by early universe standards. Most young galaxies were chaotic places where supernova and colliding stars polluted interstellar gas with heavier elements over time. But NGC 1277's clusters hint at a more isolated, quieter birth, one where the raw materials for star formation were never replenished or enriched. It's as if this galaxy emerged from a cosmic desert, far from the bustling stellar factories that peppered the early universe. Another possibility is that these clusters are survivors of a much larger population that was violently stripped away. Some theories suggest NGC 1277 might have once been part of a denser galactic group, where gravitational tugs of war ripped apart younger, metal-richer clusters, leaving only the oldest and most resilient behind. Imagine a storm sweeping through a forest, only the deepest-rooted trees remain standing. If true, this would mean the galaxy's current clusters are the last witnesses to a dramatic upheaval we can no longer see. Then there's the black hole factor, the same behemoth that may have quenched star formation in NGC 1277 could have also influenced its clusters. Intense gravitational forces from the black hole might have disrupted the formation of newer clusters or expelled the gas needed to create them. It's a cosmic catch-22. The very engine that shaped the galaxy's evolution also left its stellar neighborhoods frozen in time. The most tantalizing question is whether these clusters are indigenous to NGC 1277 or intergalactic orphans captured later. Some astronomers propose they could be remnants of smaller galaxies torn apart and absorbed billions of years ago. If so, their metal-poor composition suggests those victim galaxies were themselves relics of the universe's dawn, tiny, primitive building blocks that never evolved. Whatever their origin, these clusters are more than just celestial curiosities. They force us to rethink how galaxies assemble their stellar entourages. If NGC 1277's clusters are typical of relic galaxies, it would mean the early universe had a distinct flavor of star formation, one that favored sparse, metal-poor environments over the chaotic, enriched ones we often envision. Future telescopes like the James Webb Space Telescope could analyze their starlight for finer details, potentially rewriting the story of how the first galaxies took shape. As we move forward, another puzzle awaits: the strange absence of satellite galaxies around NGC 1277. If this galaxy is indeed a relic, why does it seem to travel alone through the cosmos, and what does that solitude reveal about its past? Now, let's unravel another cosmic oddity surrounding NGC 1277, the baffling absence of satellite galaxies. Most galaxies of its size, like our Milky Way, are surrounded by an entourage of smaller satellite galaxies, cosmic companions that orbit like moths around a flame. But NGC 1277 stands alone, a solitary giant with no visible satellites. This isn't just unusual, it's a direct challenge to our understanding of how galaxies form and evolve. The mystery begins with the basics. Satellite galaxies are thought to be the leftover building blocks of larger galaxies, remnants of the chaotic mergers and collisions that shaped the universe's structure. They're also crucial markers of a galaxy's history, like breadcrumbs leading back to its formative years. For a galaxy as massive as NGC 1277 to lack these satellites is like finding a towering oak tree with no roots. It defies logic. So, where did they go? One possibility is that NGC 1277 devoured them. Galaxies are voracious predators, and over billions of years, gravitational forces can drag smaller satellites into their larger neighbors, tearing them apart and assimilating their stars. If this happened, the evidence might still be hidden in faint stellar streams, ghostly trails of stars left behind, but so far these have been elusive. It's like searching for footprints in a wind-blown desert. The traces may have faded beyond detection. Another theory is that satellite galaxies never formed around NGC 1277 in the first place. This would imply the galaxy emerged in an unusually barren pocket of the early universe, a place where dark matter, the invisible scaffolding that helps galaxies clump together, was sparse. Without enough dark matter to anchor them, smaller galaxies might have struggled to coalesce, leaving NGC 1277 in solitary splendor. Picture a city built in the middle of an empty plain with no neighboring towns for miles. That's the kind of isolation we're talking about. Then there's the Relic Galaxy angle. If NGC 1277 is indeed a pristine survivor from the early universe, its lack of satellites might be a relic of those ancient times. In the universe's youth, large galaxies were rare, and the processes that spawned satellites like mergers and collisions may not have been as common. Over time, as the universe grew denser, other galaxies accumulated satellites, but NGC 1277, frozen in its primordial state, never did. This isolation could also be tied to the galaxy's supermassive black hole. The same gravitational forces that suppress star formation might have disrupted the formation or stability of satellite galaxies, either ejecting them or preventing them from ever taking shape. Imagine a powerful wind scattering seeds before they can take root. That's the kind of influence a black hole like this might wield. The absence of satellites isn't just a curiosity, it's a clue. If future observations confirm that relic galaxies like NGC 1277 consistently lack satellites, it could reshape our models of galaxy evolution. It would suggest that the early universe had a different rulebook for how galaxies grew, one where isolation was more common than we thought. As we move forward, another enigma beckons. The high-speed stars racing through NGC 1277, their motions defying the galaxy's gravity. What forces are hurling them so violently, and what secrets do they hold about this cosmic oddball? Now, let's turn our attention to another breathtaking phenomenon in NGC 1277, stars hurtling through space at unimaginable speeds. These aren't your typical celestial wanderers. They're high-velocity stars racing so fast that they defy the galaxy's gravitational grip, their motions painting a chaotic yet fascinating portrait of NGC 1277's turbulent core. What exactly causes these stars to move so violently? The answer lies in the galaxy's monstrous black hole, a gravitational titan whose pull is so intense it can slingshot stars to extreme velocities. Imagine a cosmic game of pinball where stars are the balls and the black hole is the flipper, launching them in all directions at breakneck speeds. This isn't just random chaos, though. It's a direct consequence of the black hole's overwhelming influence on its surroundings. These high-speed stars create what astronomers call velocity dispersion, a measure of how wildly their speeds vary from one another. In most galaxies, stars move at relatively predictable velocities like cars on a highway. But in NGC 1277, the dispersion is off the charts, more like a demolition derby with no rules. This tells us something crucial. The galaxy's core is a gravitational war zone where the black hole's dominance reshapes everything in its path. So, what does this mean for NGC 1277's overall stability? The effects are profound. High-velocity dispersion can prevent stars from settling into orderly orbits, disrupting the galaxy's structure over time. Picture a spinning top wobbling uncontrollably. That's the kind of instability we're talking about. Without the calm, balanced motion seen in most galaxies, NGC 1277's long-term evolution becomes unpredictable. Some stars might escape entirely, flung into intergalactic space like cosmic outcasts, while others could plunge into the black hole, fueling even more violent activity. This frenzy of motion also raises questions about the galaxy's past. Were these stars always so unruly, or did a cataclysmic event, like a near-miss collision with another galaxy, send them into chaos? The answer might lie in their chemical composition. If these stars are richer in certain elements, it could hint at a violent history of mergers or collisions that stirred them up. Alternatively, their speed might simply be the result of the black hole's relentless pull, a constant gravitational drumbeat driving their motion. The implications stretch beyond NGC 1277. Studying these high-speed stars helps astronomers understand how supermassive black holes shape their host galaxies. It's a glimpse into the extreme physics governing some of the universe's most dynamic environments. And if NGC 1277 is indeed a relic galaxy, these stars might preserve clues about the early universe's conditions where such gravitational extremes were more common. As we piece together this puzzle, another layer of mystery awaits. The galaxy's strikingly thin disk, a feature that defies expectations for a system this massive. How does such a delicate structure survive amid all this chaos? The answers could rewrite what we know about galactic formation. Now, let's shift our gaze to another enigma in NGC 1277, a feature so delicate it seems almost out of place amid the galaxy's gravitational turmoil. Unlike most galaxies of its size, which boast thick, sprawling disks, NGC 1277 flaunts an unusually thin disk, a razor-sharp structure that defies expectations. How does such a fragile-looking disk survive in a galaxy dominated by a monstrous black hole and high-speed stars? The answer might lie in a cosmic balancing act few galaxies achieve. To understand why this thin disk is so bizarre, picture a typical spiral galaxy like our Milky Way. Its disk is a hearty mix of stars, gas, and dust, hundreds of light-years thick, a bustling, layered metropolis. But NGC 1277's disk is more like a single sheet of paper, barely holding itself together. This stark difference raises a critical question. Did the galaxy never develop a thicker disk, or was its original structure stripped away over time? One theory points to the galaxy's early formation. If NGC 1277 emerged during a quieter, less chaotic era of the universe, it might have avoided the collisions and mergers that typically puff up galactic disks. Without these violent encounters, its disk could have remained thin, a pristine relic of a bygone cosmic age. Another possibility is that the black hole's gravitational might actually suppress disk thickening. By gobbling up nearby gas or flinging stars outward, it could have prevented the disk from expanding vertically, leaving it unusually streamlined. But there's a twist. Thin disks are fragile, vulnerable to disturbances. So why hasn't NGC 1277's disk been torn apart by the black hole's chaos or the high-speed stars whipping through it? One explanation is that the disk stars orbit in near-perfect alignment, like synchronized swimmers, minimizing collisions and keeping the structure intact. Alternatively, the disk might be younger than we think, recently reformed after a past disruption, though that would clash with the galaxy's relic status. The implications are profound. If the thin disk is primordial, it's a rare window into how galaxies looked in the early universe before mergers blurred their edges. If it's a product of the black hole's influence, it challenges our ideas about how supermassive black holes shape their galaxies. Either way, NGC 1277's delicate disk forces us to rethink the rules of galactic architecture. As we marvel at this cosmic wisp, another puzzle emerges. The galaxy's complete lack of spiral arms, a feature common in most disk galaxies. How did NGC 1277 end up so smooth and featureless? The clues might lie in its turbulent past. Now, let's unravel another cosmic oddity, NGC 1277's perplexing lack of spiral arms. While most disk galaxies, like our own Milky Way, flaunt majestic, swirling arms brimming with star-forming activity, this galaxy stands eerily smooth, its disk devoid of any such features. The absence is startling, raising a burning question. Was this galaxy born without spiral arms, or did some catastrophic event wipe them clean? To grasp why this matters, picture a typical spiral galaxy. Those elegant arms aren't just for show, they're cosmic nurseries, where dense gas clouds collapse to birth new stars. They are also traces of a galaxy's dynamic history, shaped by gravitational interactions and internal processes. So when we find a disk galaxy like NGC 1277 with no arms at all, it's like stumbling upon a city with no neighborhoods, just a vast, uniform grid. How does such a thing even happen? One possibility is that NGC 1277 never had spiral arms to begin with. Some theories suggest that galaxies forming in particularly quiet, isolated patches of the early universe might skip the spiral phase entirely, their disks too stable or their gas too evenly distributed to develop those iconic swirls. If true, this galaxy could be a frozen snapshot of an ancient, undisturbed disk, a rarity in our collision-prone cosmos. But there's a darker alternative. What if NGC 1277 once had spiral arms, only to lose them in a violent encounter? Galactic mergers or close brushes with other galaxies can disrupt delicate structures, scattering gas and stars into chaos. Over time, the galaxy's disk might have settled back into a smooth state, its arms erased like ripples fading from a pond. The galaxy's monstrous black hole could have played a role too, its gravitational fury stirring the disk enough to suppress arm formation. Yet here's the puzzle. If a past catastrophe destroyed the arms, why does the galaxy's disk remain so thin and intact? Mergers usually puff up disks, leaving them thicker and disordered. One explanation is that the event was subtle, perhaps a gentle gravitational nudge from a passing galaxy, just enough to erase the arms without fully disrupting the disk. Or maybe the black hole's influence somehow ironed out the arms, smoothing the disk while keeping it razor thin. The implications stretch beyond NGC 1277. If spiral arms can vanish without a trace, it challenges our assumptions about how galaxies evolve. Are there other bald disk galaxies lurking in the cosmos, their histories hidden in their smooth surfaces? And what does this mean for our models of galactic structure, which often treat spiral arms as inevitable features of disk galaxies? As we ponder these questions, another mystery beckons: the galaxy's peculiar dust lanes, sparse and uneven, as if painted by a hesitant artist. What secrets do these faint streaks hold about the galaxy's turbulent past? Now let's turn our gaze to another enigma: the peculiar dust lanes weaving through NGC 1277. Unlike the rich, intricate dust patterns seen in spiral galaxies, these lanes are patchy and faint, scattered unevenly across the disk like smoke from a doused fire. Their irregularity raises eyebrows because dust lanes are usually telltale signs of a galaxy's life story, tracing the flow of gas and the scars of past events. So why do these look so incomplete? Dust in galaxies isn't just cosmic decoration. It's a byproduct of stellar life cycles, ash from dying stars, heavy elements forged in supernova, all clumping together in sprawling dark clouds. Typically, this dust organizes into dense lanes along spiral arms or rings, shaped by the galaxy's rotation and gravity. But in NGC 1277, the dust seems almost hesitant, forming wispy streaks rather than bold ribbons. One explanation is that this galaxy simply ran out of raw material. Remember, it's a red and dead galaxy. With little star formation, there'd be fewer supernova to replenish the dust supply over time. What we're seeing could be the last fading traces of interstellar soot, not enough to form the dramatic lanes seen in younger galaxies, but there's another twist. The uneven distribution might hint at turbulence in the galaxy's past. Dust doesn't just fade, it can be blown away or destroyed. Intense radiation from the supermassive black hole, or even shock waves from ancient collisions, could have ripped through the galaxy's interstellar medium, scattering dust into these sparse, irregular patterns. Alternatively, the dust might have been pushed outward by stellar winds from the galaxy's aging stars, leaving behind these fragmented trails. What's especially curious is how these dust lanes compare to the galaxy's other oddities. Their patchiness aligns with the lack of spiral arms and the thin disk, all suggesting a system where structure was either never fully formed or meticulously erased. If the arms were smoothed out long ago, perhaps the dust never had a chance to gather into coherent lanes. Or if the black hole played a role in cleaning up the galaxy, its energy might have disrupted dust just as it suppressed star formation. Yet the biggest clue lies in what's missing. Dust usually glows in infrared light, warmed by starlight it absorbs. But NGC 1277's dust lanes are unusually dim at these wavelengths, implying the grains might be older, colder, or simply less abundant. This fits the Relic Galaxy narrative, a place where time froze early on, leaving interstellar material to dwindle without renewal. As we piece together this puzzle, the dust lanes offer more questions than answers. Are they remnants of a forgotten era or evidence of forces still at work? One thing's certain, their faint streaks are a silent testament to how much we still don't understand about galaxies like this. And speaking of quiet mysteries, our next stop takes us deeper into the galaxy's heart, to its strangely overmassive central bulge. Now, let's shift our focus to another striking anomaly in NGC 1277, its colossal central bulge, a feature so oversized it defies typical galactic proportions. Most galaxies have bulges, those bright, rounded cores packed with stars, but this one is something else entirely. It's as if the galaxy's heart swelled far beyond what its disk could reasonably support, leaving astronomers scratching their heads over how such an imbalance came to be. In most spiral galaxies, the bulge and disk exist in relative harmony, with the bulge making up about 10 to 20% of the galaxy's total mass. But in NGC 1277, the bulge isn't just prominent, it's downright dominant, accounting for a staggering share of the galaxy's stellar mass. This isn't just unusual, it's a direct challenge to our understanding of how galaxies assemble and evolve. So, what could explain this overgrown feature? One leading theory points directly to the galaxy's supermassive black hole. As we've seen, this black hole is exceptionally massive for a galaxy of this size, and its gravitational pull could have played a key role in shaping the bulge. Over billions of years, the black hole's intense gravity might have funneled stars inward, causing them to pile up in the core. Think of it like a cosmic vacuum, drawing stars closer and compressing them into an ever denser cluster. If true, this would mean the bulge isn't just big, it's a direct consequence of the black hole's overwhelming influence. But there's another possibility. Some scientists argue that the bulge might be a relic of the galaxy's violent youth. In the early universe, galaxies frequently collided and merged, and these chaotic encounters could have triggered bursts of star formation in their cores. If NGC 1277 formed during one of these frenzied periods, its bulge might be the fossilized remains of that ancient starburst, a time capsule from an era when stars were born in rapid, dense waves. Then there's the question of dark matter, or rather, the lack of it. We've already seen that this galaxy is strangely deficient in dark matter, and this could have left its stars more vulnerable to gravitational shifts. Without the stabilizing pull of dark matter, the stars in the disk could have migrated inward more easily, swelling the bulge over time. It's a subtle effect, but over billions of years, even small movements add up. What's particularly fascinating is how this oversized bulge ties into the galaxy's other oddities. Its lack of spiral arms, thin disk, and ancient stellar population all fit the picture of a system where the central regions hogged most of the action. If the bulge grew too dominant too early, it might have stifled the disk's development, preventing the galaxy from forming the elegant structures we see in younger, more balanced systems. Yet mysteries remain. For instance, why didn't the bulge grow even larger? If the black hole's gravity or past mergers were so influential, why stop at this size? Some researchers speculate that feedback mechanisms like winds from dying stars or energy from the black hole itself might have put a brake on the bulge's growth, creating an uneasy equilibrium between expansion and restraint. As we weigh these ideas, one thing becomes clear: the overmassive bulge isn't just a curiosity, it's a clue. Whether shaped by the black hole, forged in ancient collisions, or influenced by missing dark matter, its existence forces us to rethink how galaxies evolve under extreme conditions. And with that in mind, our next stop takes us to another puzzling feature: the galaxy's unusually low metallicity, a trait that whispers secrets about its earliest days. Now let's turn our attention to a trait that makes NGC 1277 stand out even among its peculiar peers. Its stars are strikingly metal-poor. In astronomy, metals refer to any element heavier than hydrogen or helium, and they're crucial clues about a galaxy's history. Normally, as galaxies age, successive generations of stars forge these heavier elements in their cores and scatter them into space when they die, enriching future stars with metals. But NGC 1277 bucks this trend. Its stars contain far fewer metals than expected, hinting that this galaxy might be a frozen relic from the universe's infancy. So, what does this low metallicity actually tell us? For starters, it suggests that most of NGC 1277 stars formed in a frenzied burst very early on, when the universe itself was still young and metal-poor. Back then, the cosmos hadn't yet been seeded with the heavier elements later generations of stars would produce. If the galaxy's star formation shut down soon after, as its red and dead status implies, those ancient stars never got a chance to mix with metal-rich material, preserving their primordial composition like a cosmic time capsule. This idea fits neatly with the galaxy's other oddities. Its oversized black hole, deficient dark matter, and lack of spiral arms all point to a system that formed quickly and then effectively fossilized. But here's where it gets even more intriguing. Most galaxies we see today, even ancient ones, show at least some enrichment from later star-forming episodes. NGC 1277's extreme metal scarcity implies it didn't just form early. It somehow avoided the usual cosmic recycling processes that should have peppered its stars with heavier elements over time. One possibility is that the galaxy's environment played a role. Isolated from major galaxy clusters, it might have escaped the mergers and interactions that typically trigger new star formation, and with it, metal production. Alternatively, its supermassive black hole could have played a part. If the black hole's intense energy output heated or expelled gas early on, it might have starved the galaxy of the raw materials needed to forge new, metal-rich stars. But there's a twist. Some of the galaxy's stars have slightly higher metallicity than others, creating a subtle gradient from the core outward. This could mean that, for a brief window, some metal enrichment did occur. perhaps from a handful of late-forming stars or even ingested dwarf galaxies. Yet these exceptions only deepen the mystery. Why did the enrichment process stall so abruptly? The implications stretch beyond this single galaxy. If NGC 1277 is truly a pristine relic, studying its stars could give us an unprecedented window into the conditions of the early universe. Their composition might reveal what the first generations of stars were like, how quickly galaxies could form, and even how black holes grew to such monstrous sizes so soon after the Big Bang. This leaves us with a tantalizing thought. NGC 1277 isn't just an oddball, it's a survivor, a galactic artifact preserving secrets from a time when the universe was barely out of its cradle. And as we piece together its story, we're reminded that sometimes the quietest corners of space hold the loudest echoes of cosmic history. Next up, we'll explore another puzzle, the strange X-ray emissions flickering from this enigmatic galaxy, a phenomenon that might just tie back to its ravenous black hole. Now, let's shine a light on another mystery lurking in NGC 1277, those strange X-ray emissions flickering from its depths. Normally, galaxies with supermassive black holes at their hearts emit X-rays as they consume nearby gas, heating it to extreme temperatures before swallowing it whole. But NGC 1277's X-ray signals don't quite fit the expected pattern. They're fainter and patchier than scientists anticipated, raising eyebrows across the astronomy community. So, what's causing this unusual glow? One leading theory points to the galaxy's monstrous black hole. While it's true that black holes often emit X-rays as they feed, NGC 1277's black hole appears to be on a cosmic diet. Instead of devouring gas in a continuous feast, it might be nibbling sporadically, producing only occasional bursts of X-rays. This could explain why the emissions are weaker than expected. There simply isn't enough material falling into the black hole to generate a stronger signal. But here's where it gets even more puzzling. Another possibility is that the X-rays aren't coming from the black hole at all. Instead, they might originate from vast clouds of superheated gas lingering in the galaxy. If this gas was heated by past outbursts from the black hole or collisions between stars, it could still emit faint X-rays long after the initial event. This would make the galaxy's current emissions more like the fading embers of an ancient fire, rather than the blazing inferno we'd expect from an active black hole. There's a third contender, though: cosmic leftovers. Some astronomers suggest these X-rays could be the remnants of smaller black holes or neutron stars lurking in the galaxy's outskirts. These dense stellar corpses often emit X-rays as they pull material from companion stars. If NGC 1277 harbors a population of these objects, their combined glow might create the patchy signal we observe. Yet none of these explanations fully account for the emissions' uneven distribution. Why are some regions brighter than others? One tantalizing idea involves the galaxy's violent past. If NGC 1277 once collided with another galaxy, the wreckage could have scattered pockets of hot gas or triggered brief spikes in star formation, leaving behind uneven X-ray trails. Alternatively, the galaxy's missing dark matter might play a role. Without the gravitational scaffolding dark matter provides, gas might not flow smoothly toward the black hole, leading to irregular X-ray hotspots. The implications are profound. If the black hole is truly underfed, it challenges our understanding of how these cosmic behemoths grow. Most supermassive black holes are thought to bulk up gradually over time, but NGC 1277's appears to have hit pause. Meanwhile, if the X-rays come from ancient gas clouds, they could reveal details about the galaxy's fiery youth. Even the neutron star hypothesis offers clues, potentially exposing a hidden population of dead stars. What makes this mystery especially exciting is its connection to the galaxy's other oddities. The faint X-rays align with its red and dead state, its metal-poor stars, and its isolated location. Together, they paint a picture of a galaxy that raced through its early life and then froze in time, preserving a snapshot of the universe's formative years. As we peel back the layers of NGC 1277's X-ray enigma, we're reminded that even the quietest objects in space can whisper secrets about the cosmos's most dramatic events. And with that, we're ready to explore another piece of this galactic puzzle, the rare title it holds as a so-called Relic Galaxy, a living fossil from the dawn of time. Now, let's step into the cosmic time machine and uncover what makes NGC 1277 so special, its rare title as a Relic Galaxy. This isn't just a flashy nickname. It's a label that places this galaxy among the universe's most pristine artifacts, like a fossil locked in celestial amber. But what exactly does it mean to be a relic galaxy, and why is NGC 1277 one of the very few we've found? To understand this, we need to rewind the clock. Most galaxies evolve over billions of years, growing through mergers with other galaxies, birthing new stars and transforming their shapes in the process. But relic galaxies, they're the rare exceptions that somehow avoided all that chaos. Think of them as cosmic hermits, isolated, untouched, and frozen in time. NGC 1277 fits this description perfectly because it appears almost exactly as it did roughly 12 billion years ago, when the universe was just a fraction of its current age. So how did it stay so unchanged? The answer lies in its solitude. Unlike bustling galaxies like our Milky Way, which have collided with neighbors multiple times, NGC 1277 seems to have spent most of its life alone. Without nearby galaxies to disrupt it, it never experienced the dramatic mergers that trigger star formation or reshape galactic structures. Its stars formed rapidly and early, then, for reasons still unclear, the process simply stopped. The result, a galaxy packed with ancient stars and very little of the gas needed to make new ones. But isolation isn't the only factor. NGC 1277's monstrous black hole might have played a role too. Some scientists suggest that early in its life, the black hole's intense energy could have blown away or heated up any remaining gas, effectively shutting down star formation. Combine that with the galaxy's lack of dark matter, which normally helps pull in fresh gas, and you have a recipe for a cosmic time capsule. What's truly fascinating is how few of these relics exist. Out of the hundreds of billions of galaxies in the observable universe, only a handful qualify as pristine relics. That makes NGC 1277 a goldmine for astronomers. By studying it, we're getting a direct look at what galaxies were like in the universe's infancy, free from the clutter of later evolution. Its old, metal-poor stars, its peculiar structure, even its strange X-ray emissions, all of these are clues to conditions in the early cosmos. Yet mysteries remain. Why did star formation stop so abruptly? Was it the black hole's influence or something else entirely? And how did it avoid even minor interactions over such an unimaginable time span? Each question peels back another layer of this galactic enigma. As we marvel at NGC 1277's untouched state, we're reminded that sometimes the most extraordinary discoveries aren't about dramatic changes, but about what stays the same. And with that, we turn to another puzzle, the curious silence of this galaxy's radio waves, a quiet that defies expectations. But here's something that doesn't add up. NGC 1277 is eerily quiet. Now, let's tune into the mystery of its radio silence. Most galaxies with supermassive black holes at their cores are anything but silent. These cosmic giants usually announce their presence with roaring radio emissions, created by jets of particles blasting outward at near light speeds. Yet, despite its colossal black hole, one of the most massive we've ever found, NGC 1277, emits barely a whisper in radio waves. This isn't just unusual. It's like finding a volcano that never erupts. So why the quiet? One possibility is that the black hole is in an unusually dormant state. Black holes aren't always active. They go through cycles of feeding and fasting, depending on how much material falls into them. If NGC 1277's black hole has run out of nearby gas to consume, it might have temporarily shut down its particle jets, leaving the galaxy in radio silence. But here's the catch: this galaxy's black hole is so massive that it should have plenty of gravitational pull to keep drawing in material, even from sparse surroundings. The fact that it isn't suggests something else is at play. Another theory points to the galaxy's strange lack of dark matter. Dark matter doesn't just influence a galaxy's structure, it also helps funnel gas toward the center, feeding the black hole. Without it, NGC 1277's black hole might be starved of fuel, unable to power the energetic processes that create radio emissions. This could explain why, despite its size, the black hole isn't lighting up the radio spectrum. Then there's the relic factor. If NGC 1277 truly is a frozen relic from the early universe, its black hole might have been more active billions of years ago, back when the galaxy still had gas to spare. Over time, as star formation ceased and gas supplies dwindled, the black hole's activity could have dwindled too, leaving behind a silent behemoth. We might be seeing it in a rare, dormant phase, one that could last for eons. But there's a twist. Some astronomers suggest that the radio silence might not be permanent. If NGC 1277 were to collide with another galaxy, unlikely given its isolation but not impossible, the influx of fresh gas could reawaken the black hole, turning this quiet giant into a radio powerhouse. Until then, its silence remains a tantalizing puzzle. What makes this mystery so compelling is that it challenges our assumptions about how black holes behave. We're used to linking supermassive black holes with loud, energetic activity, but NGC 1277 forces us to reconsider. Maybe quiet giants like this are more common than we thought, lurking undetected in the cosmic background. Or perhaps this galaxy is hiding an even stranger secret, one we've yet to uncover. As we ponder the significance of this radio silence, another puzzle comes into focus: the faint traces of stellar streams winding around the galaxy, ghostly clues to a past that might not have been as lonely as it seems. Now, shifting our gaze slightly, let's unravel the ghostly whispers of NGC 1277's past, the unresolved stellar streams swirling around it. These faint, ribbon-like trails of stars are cosmic breadcrumbs, hinting at violent encounters long forgotten. Most galaxies bear scars from collisions or close calls, but NGC 1277 streams are particularly intriguing. They're subtle, almost elusive, suggesting interactions so ancient that time has nearly erased them. What could have left these marks? One compelling theory points to dwarf galaxies, small, faint companions that may have strayed too close. Over billions of years, NGC 1277's immense gravity could have stretched and shredded these trespassers, scattering their stars into the delicate streams we see today. The fact that the streams are so diffuse suggests these encounters happened far in the past, perhaps when the universe was only half its current age. But there's a twist. Unlike typical galaxies, NGC 1277 has no visible satellite galaxies nearby today. This raises a question: did it devour all its neighbors, leaving only these faint streams as evidence? Or were the streams created by a single, dramatic collision with a larger galaxy, one forceful enough to leave lasting scars without fully disrupting NGC 1277's pristine, relic-like state? The timing of these events is another puzzle. If the streams are remnants of ancient mergers, they could date back to a time when the universe was more crowded and galaxies collided frequently. This would align with NGC 1277's status as a relic, a galaxy that stopped evolving early on. Alternatively, the streams might be younger, formed during a rare, more recent encounter. Without precise measurements of the star's ages, their origins remain speculative. Then there's the mystery of the stream's structure. Unlike the neat, tidal tails seen in other galaxies, NGC 1277 streams are fragmented and uneven. This could mean the galaxy interacted with multiple small objects rather than one large one, or that its unique environment lacking dark matter affected how the streams formed. Dark matter usually acts like cosmic glue, shaping how galaxies tear each other apart during collisions. Without it, the physics of these encounters might have played out very differently. What's next for these ghostly trails? Future telescopes with sharper vision could map them in greater detail, revealing the motions and compositions of their stars. If the stars are old and metal-poor, they'd support the ancient merger theory. If they're younger or richer in metals, they might point to a more recent event. Either way, these streams are a silent testament to a turbulent past hiding beneath NGC 1277's calm exterior. As we piece together these stellar whispers, another enigma emerges: the galaxy's surprising abundance of red giants, aging stars that tell their own story about NGC 1277's life cycle. But that's a tale for another moment. Now, let's turn our attention to another striking feature of NGC 1277, its overabundance of red giant stars. These bloated, aging stars glow with a distinct reddish hue, and their prevalence in this galaxy tells a fascinating story about its past and what lies ahead. Unlike younger galaxies brimming with blue, hot stars, NGC 1277's population is dominated by these cooler, older giants, signaling a celestial retirement home of sorts. So, what does this abundance of red giants reveal? First, it confirms that NGC 1277's star-forming days are long over. Red giants are stars in the late stages of their lives, ones that have exhausted the hydrogen fuel in their cores and expanded dramatically as they fuse heavier elements. Their sheer numbers suggest the galaxy underwent a burst of star formation billions of years ago, creating a generation of stars that are now reaching their twilight years together. Think of it like a town where nearly everyone is elderly. It's a clear sign that no new residents have arrived in a very long time, but there's more to it than just age. The concentration of red giants also hints at how quickly NGC 1277 burned through its gas supply. Most galaxies recycle gas from dying stars to form new ones, but this one seems to have shut down the process entirely. Whether due to its massive black hole gobbling up material, a lack of fresh gas from cosmic surroundings, or some other mechanism, the galaxy's star formation didn't just slow, it stopped abruptly. Interestingly, the red giants here might also hold clues about the galaxy's initial conditions. Stars born in the early universe tend to be metal-poor, meaning they contain fewer elements heavier than hydrogen and helium. If NGC 1277's red giants are especially metal-poor, it would reinforce its status as a relic galaxy, one that's preserved the pristine conditions of the ancient cosmos. Observations of their light spectra could help settle this, offering a snapshot of the galaxy's chemical makeup during its fiery youth. Looking ahead, the fate of these red giants is just as intriguing. Over millions of years, they'll shed their outer layers, forming beautiful planetary nebulae before collapsing into dense white dwarfs. With so many stars on this path, NGC 1277 could eventually become a galaxy filled with these faint stellar embers, quietly fading into cosmic history. Yet the story doesn't end there. The sheer number of these aging stars raises another question: was there ever a time when NGC 1277 blazed with the light of countless young stars? If so, what snuffed out that brilliance so completely? As we ponder this, another puzzle awaits: the galaxy's baffling absence of neutral hydrogen, the raw fuel for star birth. But that's a mystery for another moment. Moving deeper into the enigmas of NGC 1277, we stumble upon a glaring absence: the missing neutral hydrogen gas that should, by all cosmic expectations, be present in this galaxy. Neutral hydrogen is the universe's fundamental building block for star formation, the raw, cold gas that collapses under gravity to ignite new stellar fires. Yet here, in this relic of the ancient cosmos, it's conspicuously scarce. What happened to it? Did it vanish, or was it never there to begin with? This isn't just a minor detail, it's a cosmic whodunit with implications for how galaxies live and die. Most galaxies, even those considered red and dead, hold onto reservoirs of neutral hydrogen, a silent promise that star formation could one day reignite. But NGC 1277 breaks the mold. Observations using radio telescopes, which excel at detecting the faint whispers of this gas, have come up startlingly empty. This suggests one of two possibilities. Either the galaxy was born in an unusually hydrogen-poor environment, defying typical formation scenarios, or something stripped it away with ruthless efficiency. Let's explore the first scenario. Could NGC 1277 have formed without much neutral hydrogen to begin with? If true, this would make it a rare oddity. Galaxies usually emerge from vast clouds of primordial gas, so a lack of hydrogen would imply it originated in a peculiar cosmic desert, starved of the very material needed to build stars. Some theories propose that certain regions of the early universe might have had uneven gas distributions, leaving pockets like this galaxy bereft. Yet even if that were the case, neighboring galaxies or intergalactic winds should have deposited trace amounts over billions of years. The absence is too absolute for comfort. That brings us to the second possibility: forcible removal. One prime suspect is the galaxy's supermassive black hole, whose gravitational might could have heated and expelled hydrogen gas in violent outbursts. We see this in other galaxies with active cores, where jets and radiation blast gas outward. But here's the twist: NGC 1277's black hole isn't actively feeding, making this explanation less tidy. Alternatively, the galaxy might have endured a traumatic encounter, perhaps a high-speed collision with another galaxy or a plunge through a dense cluster where external forces ripped its gas away. Yet there's no obvious evidence of such an event in its current, isolated state. Another clue lies in the galaxy's ancient stars. If they're as metal-poor as suspected, it suggests NGC 1277 never had much gas to recycle into later generations of stars. In essence, it burned through its initial supply in one frenzied burst, leaving nothing behind. This would align with its Relic Galaxy label, a snapshot of a time when the universe was younger and gas was more pristine but perhaps less abundant. The implications are profound. Without neutral hydrogen, NGC 1277 isn't just retired, it's permanently closed for business. No new stars will light its skies, no planetary systems will form. It's a fossil frozen in time, and while that makes it a treasure trove for astronomers studying the early universe, it also underscores how fragile the balance of cosmic ingredients can be. One missing piece and an entire galaxy's destiny shifts. Now, as we piece together this puzzle, another layer emerges: the galaxy's unusually high surface brightness, a glow that defies expectations given its lack of star-forming fuel. How does a galaxy shine so brightly without the usual suspects? But that's a story for another moment. But here's something that makes NGC 1277 even more baffling: its unusually high surface brightness. You'd think a galaxy with no star-forming gas and ancient stars would fade into the cosmic background, but this one refuses to go quietly. It shines far brighter than expected for its size and age, and that's a puzzle astronomers are still trying to crack. So what's behind this unexpected glow? One key factor is the sheer density of its stars. Unlike spiral galaxies with their sprawling arms or diffuse dwarfs, NGC 1277 packs its stars into a tight, compact space. Imagine a stadium where every seat is filled. Light from each star adds up, creating an intense collective brightness. This galaxy is like that, a stellar metropolis where stars are crowded together, amplifying its radiance. But density alone doesn't explain everything. The stars themselves play a starring role. Many of them are red giants, aging stars that have ballooned in size and luminosity as they near the end of their lives. These giants pump out far more light than younger, smaller stars, acting like cosmic floodlights in an otherwise dim neighborhood. Combine that with the galaxy's lack of obscuring dust, no thick lanes to block their light, and you've got a recipe for a strikingly bright galaxy. Then there's the black hole's ghostly influence. While it's not actively devouring matter now, it may have shaped the galaxy's past. Some theories suggest that earlier bursts of activity heated the surrounding gas, preventing it from cooling and forming new stars. That left the galaxy with only its oldest, brightest stars, further boosting its surface brightness. It's as if the black hole indirectly curated the galaxy's glow by halting star formation entirely. Could there be another culprit? Possibly. NGC 1277 status as a relic galaxy means it avoided the chaotic mergers that reshape most galaxies over time. Without younger, dimmer stars muddying the mix, its light remains undiluted. Other galaxies get watered down by new additions, but this one stayed pure, preserving its original brilliance. The implications are fascinating. High surface brightness often signals recent star formation, but here it's the opposite, a relic of extreme age. That challenges how we interpret similar galaxies across the universe. Are they young and vibrant or ancient and pristine? NGC 1277 forces us to reconsider the rules, and yet even this glow hides secrets. Some regions shine brighter than others, hinting at pockets of higher density or unusual stellar chemistry. Future telescopes might reveal whether these variations hold clues to the galaxy's formation, or if they're just another layer of its enduring mystery. Now, as we peer closer, another oddity comes into focus. The peculiar way stars move within this galaxy, defying the usual patterns. But that's a twist best saved for the next discovery. Turning our attention to the movement of stars within NGC 1277, we encounter yet another cosmic puzzle. This galaxy doesn't just look unusual, it behaves strangely too. Normally, stars in galaxies follow predictable paths, rotating in orderly orbits around the center. But here, the stars seem to be dancing to a chaotic tune, moving in ways that baffle astronomers. The first clue lies in their speed. Stars near the galaxy's outer edges are whizzing around far faster than expected. In most galaxies, stars farther from the center slow down like planets in our solar system. But in NGC 1277, they maintain high velocities, almost as if some unseen force is pushing them along. This flouts our standard models of galactic rotation, where gravity from visible matter should dictate the motion. So what's causing this anomaly? One leading suspect is the galaxy's missing dark matter. Dark matter typically acts as an invisible scaffold, providing extra gravitational pull to keep stars moving at observed speeds. But since NGC 1277 already lacks dark matter, scientists are left scratching their heads. Without this hidden glue, the star's high speeds become even more perplexing. Then there's the black hole's role. With a mass billions of times that of our Sun, its gravity is monstrous enough to influence the entire galaxy. Some theorists argue that past outbursts from the black hole, violent jets or radiation, could have shocked the surrounding stars, sending them into these erratic orbits. Imagine a pebble tossed into a pond. The ripples disturb the water's surface. Similarly, the black hole's past activity might have sent gravitational ripples through the galaxy, disrupting stellar motions for eons. But not everyone agrees. Alternative explanations suggest that NGC 1277's isolated history plays a part. Most galaxies grow by merging with others, which scrambles their stars' orbits. Because this relic galaxy avoided such chaos, its stars may have preserved ancient kinematic patterns we no longer recognize. It's like finding a fossil with a strange anatomy. Modern creatures don't move that way, but ancient ones might have. The debate reveals a deeper challenge. Our models of galaxy dynamics are built on typical modern galaxies. NGC 1277, pristine and untouched, forces us to question whether those models need rewriting. Perhaps its kinematics aren't strange at all. Perhaps they're a window into how galaxies behaved in the early universe before dark matter became dominant. Yet mysteries remain. Some stars move in tight, fast loops near the center, while others streak outward at odd angles. This mismatched motion hints at complex forces at work, possibly a tug of war between the black hole's gravity and the star's own momentum. Upcoming telescopes could untangle this web by mapping individual star paths with unprecedented precision. As we piece together this kinematic puzzle, one thing is clear: NGC 1277 refuses to fit neatly into our cosmic categories. Its star's wild dance challenges us to rethink not just this galaxy, but the very rules governing all galaxies. And with that, we're drawn to another enigma: why such a massive black hole sits quietly at its heart, showing no signs of the violent activity we'd expect. But that's a story for the next revelation. Now, shifting our gaze to an even deeper cosmic conundrum, we come across a baffling silence at the heart of NGC 1277. This galaxy harbors one of the most massive black holes ever discovered, a behemoth with a gravitational grip billions of times stronger than our Sun. Yet, against all expectations, this colossal monster is eerily quiet. Unlike most supermassive black holes, which devour surrounding matter in a spectacular display of energy, NGC 1277's central giant shows no signs of an active galactic nucleus or an. This absence is startling. Active galactic nuclei are cosmic powerhouses, lighting up the universe with blazing jets of radiation and particles as black holes feast on gas, dust, and stars. Think of them as cosmic lighthouses, signaling their presence across vast distances. Nearly every galaxy with a black hole of this size should have one, but NGC 1277 defies the norm. Its silence is so profound that astronomers initially double-checked their instruments, thinking they'd made a mistake. So why the quiet? One explanation points to diet. Black holes need fuel to shine. If NGC 1277's black hole has simply run out of nearby matter to consume, it would enter a dormant state. This could happen if the galaxy's gas was stripped away long ago, or if the black hole devoured everything within reach, leaving nothing to spark new activity. Imagine a campfire that's burned through all its logs. It eventually dies down to embers, but there's a twist. Some dormant black holes occasionally flicker back to life when stray gas clouds drift too close. The fact that this one remains persistently silent suggests something more unusual. Perhaps its environment is exceptionally clean, with no wandering gas or stars to reignite it. Or maybe its past eruptions were so violent that they cleared out the entire neighborhood in one go, like a cosmic vacuum cleaner. Another possibility challenges our assumptions about black hole behavior. Could this black hole be fundamentally different from others? Some theories suggest that black holes in relic galaxies like NGC 1277 might have formed under unique conditions in the early universe, leading to alternate growth paths. Instead of feeding continuously, it might have gulped down huge amounts of matter all at once in the distant past, then entered a permanent state of inactivity. Then there's the timing factor. AGN activity often comes in cycles, with long periods of quiet between outbursts. If we're observing NGC 1277 during an exceptionally long hiatus, its silence might just be temporary. Future observations could catch it waking up, though so far there's no hint of that happening. The implications stretch beyond this single galaxy. If massive black holes can exist without AGN, it forces us to reconsider how they influence their host galaxies. Traditionally, AGN feedback, the energy blasts from active nuclei, is thought to regulate star formation and galaxy growth. But in NGC 1277, that mechanism appears switched off. How then did this galaxy stabilize its structure without such feedback? The answer might lie in its relic status, preserving ancient conditions where different rules applied. This quiet giant also raises practical questions for astronomers. How many other massive black holes are lurking undetected because they're not actively feeding? Current surveys rely heavily on AGN emissions to find supermassive black holes. If more like this one exist, our census of these cosmic monsters might be wildly incomplete. As we unravel the mystery of this silent titan, we're reminded that the universe still holds surprises in plain sight. NGC 1277's black hole defies expectations not by what it does, but by what it doesn't do, and that absence speaks volumes. Next, we'll examine how this galaxy's color gradients add yet another layer to its enigma, revealing subtle clues about its storied past. Now, let's turn our attention to another striking feature of NGC 1277, its unusual color gradient. Most galaxies display a predictable shift in color from their core to their outer edges, but this Relic Galaxy bucks the trend in a way that has astronomers scratching their heads. The colors of a galaxy aren't just aesthetic, they're cosmic fingerprints revealing the ages, compositions, and even the life stories of its stars. And NGC 1277's gradient tells a tale that's anything but ordinary. Typically, galaxies like our Milky Way show a gradual transition from a yellower, redder center to bluer spirals at the edges. The core's reddish hue comes from older, cooler stars, while the outskirts often host younger, hotter stars that glow blue. But NGC 1277 flips this pattern on its head. Its core is oddly bluer than expected, while the outer regions lean more toward red, a reversal that challenges our understanding of how galaxies evolve. So what's behind this peculiar palette? One leading theory points to the galaxy's ancient star-forming history. Unlike most galaxies which continuously birth new stars, NGC 1277 seems to have shut down star formation billions of years ago. Its core might retain a population of intermediate-aged stars, not the ancient red giants we'd expect, but slightly younger stars that still emit a bluer light. These stars could be relics of the galaxy's last major burst of activity before it went dormant, frozen in time like cosmic artifacts. Another possibility involves metallicity, the amount of heavy elements mixed into the stars. Older stars tend to be metal-poor, forming before later generations enriched the universe with elements like iron and silicon. If NGC 1277's outer regions are dominated by these ancient metal-poor stars, their reddish glow would make sense. Meanwhile, the core might harbor stars with slightly higher metallicity, perhaps from a brief period of late-stage star formation, giving them a bluer tint. It's like finding a patch of vibrant wildflowers in an otherwise barren desert, a small clue to a forgotten era of growth. There's also the role of the galaxy's extreme environment to consider. With its supermassive black hole and lack of dark matter, NGC 1277 endured conditions rare in the modern universe. If violent gravitational forces or past interactions selectively stripped away certain stars or gas, they could have left behind an uneven distribution of stellar ages and types, creating this atypical color gradient. Picture a painter's canvas where some colors were scraped away unevenly, leaving behind a patchy, unpredictable masterpiece. But perhaps the most intriguing explanation ties back to the galaxy's relic status. As a pristine survivor from the early universe, NGC 1277 may have formed stars under different rules than modern galaxies. Its unusual color gradient could be a snapshot of those primordial conditions, a rare glimpse into how the first galaxies assembled their stellar populations. If so, studying this gradient isn't just about solving a puzzle, it's about unlocking secrets from the dawn of cosmic time. This odd coloring doesn't just add to the galaxy's mystery, it forces us to rethink how we interpret color in galaxies altogether. Astronomers often use color as a quick way to estimate a galaxy's age or star-forming activity. But NGC 1277 warns us that the universe doesn't always follow the rules we've written. Its gradient is a reminder that outliers can reveal gaps in our knowledge, pushing us to refine our models and ask better questions. As we piece together the story behind these colors, we're not just studying a single galaxy, we're testing the boundaries of what we know about galactic evolution. Next, we'll explore how NGC 1277's isolation in the cosmic void might have preserved its ancient, unchanged state, and what that means for our search for other relics hidden in the universe's depths. Now, shifting our cosmic perspective, let's examine one of the most defining yet overlooked aspects of NGC 1277, its solitude. Unlike most galaxies which huddle in clusters or dance in gravitational tangos with neighbors, this ancient relic floats in a quiet pocket of the universe, far from the bustling crowds of galactic cities. This isolation isn't just a footnote, it's likely the key to why NGC 1277 remains a pristine time capsule from the early universe. Think of galaxy clusters as cosmic metropolises, dynamic, crowded, and constantly evolving. Galaxies there collide, merge, and tug at each other with gravity, sparking new star formation or stripping away gas and dust. But NGC 1277 is more like a hermit's cabin deep in the woods, untouched by the chaos. Its remote location, millions of light-years from the nearest major cluster, has shielded it from the gravitational upheavals that reshape most galaxies over billions of years. Without these disruptive encounters, its old stars, unusual structure, and even that puzzling color gradient have remained frozen in time, offering us an unspoiled glimpse into the past. This isolation also explains the galaxy's lack of dark matter, a mystery we explored earlier. In dense clusters, dark matter acts like cosmic glue, holding galaxies together during violent interactions. But NGC 1277, drifting alone, may have never accumulated much dark matter to begin with, or lost it long ago in a rare, ancient encounter. Either way, its loneliness preserved a composition unlike modern galaxies, making it a rare laboratory for studying the universe's raw ingredients. But how did it end up so alone? One theory suggests it was born in a now-vanished protocluster, a primordial gathering of galaxies that dispersed over time, leaving NGC 1277 behind like a lone survivor. Another idea posits that it was ejected from a cluster eons ago, flung into the void by gravitational slingshots, or perhaps it simply formed in a sparse region of the early universe where few other galaxies took root. Whatever the reason, its isolation has been its preservation. The absence of nearby galaxies also means NGC 1277 hasn't been fed by smaller satellite galaxies, a common way galaxies grow. Most large galaxies, like our Milky Way, cannibalize dwarfs over time, absorbing their stars and gas. But NGC 1277's missing satellites, another oddity we've discussed, left it to evolve in quiet austerity, never bulking up or refreshing its stellar population. This explains why its stars are uniformly old and why it's stuck in a red and dead state, with no new stars to rejuvenate its appearance. Yet this isolation might be fleeting. Astronomers speculate that NGC 1277 could, in the distant future, drift into a cluster's gravitational pull. If that happens, the same forces that preserved it for billions of years would finally disrupt it, tearing away its uniqueness. For now, though, its solitude is a gift, a chance to study a galaxy that defies the norms simply because it's been left alone. As we close this cosmic tour, let's reflect on how NGC 1277's isolation ties together its many mysteries. From its overmassive black hole to its missing dark matter, each enigma makes more sense in the context of a galaxy untouched by time and traffic. It's a reminder that in the universe's grand story, sometimes the most revealing chapters are written in the quietest corners. As we reach the end of our cosmic journey through NGC 1277, it's time to step back and marvel at just how much this peculiar galaxy has reshaped our understanding of the universe. From its monstrous central black hole, so massive it defies all expectations, to its eerie lack of dark matter, every strange object we've uncovered tells a story that challenges the textbooks. This galaxy is a rebel, a cosmic outlier that refuses to fit neatly into the categories we've built. Think about it. Most galaxies follow predictable patterns: spiral arms, bustling star formation, bustling clusters of neighbors. But NGC 1277, it's a relic frozen in time, with ancient stars that whisper secrets from the universe's youth. Its ultra-compact dwarfs, those dense stellar survivors, might be remnants of galaxies long gone, while its ghostly gas filaments hint at violent pasts we can only guess at. And let's not forget that bizarre red and dead label, a galaxy that gave up on making new stars billions of years ago, leaving astronomers scratching their heads. Then there's the silence: no radio emissions from its black hole, no active nucleus blazing with energy. It's as if the galaxy's heart is in hibernation, a puzzle wrapped in enigma. Even its isolation, which we just explored, plays a starring role in its mystery. Far from the gravitational hustle of clusters, NGC 1277 has avoided the chaos that shapes most galaxies, preserving its oddities like a cosmic time capsule. But here's the thrilling part: every anomaly in NGC 1277 isn't just a quirk, it's a clue. Its overmassive bulge, its missing satellites, even that strange color gradient from center to edge, they all force us to rethink how galaxies form and evolve. Maybe some galaxies don't follow the rules we've written. Maybe the universe has more surprises lurking in the shadows. So, what's next? If a single galaxy can upend so many assumptions, imagine what else is out there, hidden in the vast darkness. What other relics might be drifting undetected, waiting to rewrite the cosmic story? That's the beauty of astronomy. Every answer leads to new questions. Now, we'd love to hear from you. Which of NGC 1277's mysteries fascinates you the most? Is it the black hole that shouldn't exist, the missing dark matter, or something else entirely? Drop your thoughts in the comments below. Let's keep the conversation as boundless as the universe itself. And if you've enjoyed this deep dive into the cosmos, don't forget to like, subscribe, and hit that notification bell so you never miss a journey into the unknown. Until next time, keep looking up.